Hi there everybody. Right, today we are going to look at alternate segment theorem and we're going to look at the proof of it. Alright, so there's an awful lot kind of going on, so you might need to revisit this at a later stage, but essentially we're going to try and prove it. Okay, so we want to prove that x is the same as y. Well, that's what we're trying to get to. So this one is the same as this one. Alright, so tangent and obviously a triangle, those two are supposed to be the same. Okay, so let's prove it. So what we need to do to prove it is, as with many circle theorem proofs, we're going to put some lines to the center. All right, so some lines to the center to form a bunch of radiuses. Okay, so first things first, in terms of what I know about tangents and obviously radiuses, is that meets at a right angle. All right, so that meets at a right angle, and I also know that these two radiuses are both the same. And then I'm going to try and put some information in. Right, so this forms an isosceles as two radiuses are both the same. So this is isosceles triangle here over here. All right, so call the equal angles in there z. All right, so we'll call this one and this one as z. All right, we know that z plus y is 90 degrees. I mentioned that, but we'll come to that in a second. And then we've got this one. All right, well this one is going to be 180 to take away these two. All right, I also know that this one is half this one. All right, because that's angles at the center, double that at the circumference. All right, so let's see what we can put down. So let's write all that down. So this one over here is 180 take away 2z. All right, so that's that one there. All right, so I'm saying an awful lot, but of course it's really writing things down and not being afraid to just kind of dive in there and write down what it is that you know. All right, because I'm not doing anything here which is miraculous. It's about angles in triangles. It's about using isosceles triangles, and of course it's about just using algebra. So 180 take away 2z. Right, we know, and again from another circle theorem proof, that this one here is half this one. All right, so that's going to be half of this, so it's going to be 90 minus z. All right, so x is 90 minus z over there. Happy with that? Right, so we know that x is 90 minus z, so that's that one, and I want to show that this is this one over here. All right, well I know that z plus y is 90. I said that a minute ago. Z plus y is 90. So if I rearrange this one here to see what y is, well, y is 90 minus z. And by rearranging this, there, if you look at it, well, if y is 90 minus z and x is 90 minus z, then they're both the same thing, aren't they? X is equal to y because they're both 90 minus z. There, so x equals y. So your yellows are equal to each other. So we're using a couple of rules to help us kind of apply that circle segment theorem. All right. Well, that's it. That's it. There's nothing more I can say. All the proof is there for you to kind of look at. If you obviously need to revisit, then feel free to kind of come back and look at any particular time. All the content is on maths-school.co.uk, and of course, if you want to practice just some questions on alternate segment theorem, then you can. All right. But thanks for listening.